exponential functions, when we have the unknown as the power, they fall into another category other than we've already talked about power functions where the unknown is the base. When the unknown is up there as an index, we call them exponential functions. So in this case, a and b are both constants, and x is the independent variable. So this is an example of a exponential function. The graphs of those are quite interesting. We say a is equal to 1, and we've got y equals 3 to the x. And we want ourselves, what does that look like? Well, here our b is 3, a is 1. When x is equal to 0, which is the y-intercept, we're going to have 3 to the 0 is 1, so it's going to start there. And the graph will increase as we go out in positive x direction. Okay, so notice the point 1. Y equals, so that's y equals 3 to the x, y equals 2 to the x. It's going to have a similar shape. It's also going to go through there, so we might do that in red. And y equals 2 to the x. Also goes through the point 0, 1, but it won't increase as steeply as y equals 3 to the x. What happens when we've got our base being less than 1? So y equals 0.5 to the power of x. Or once again, when x is equal to 0, y is equal to 1. So maybe we'll make 1 up there. And as you increase x, this result of raising it to a number less than 1 raised to a power, the bigger x gets, the smaller this gets. So 0.5 to the power of 4 is much less than 0.5 to the power of 2. So what's going to happen is the graph is going to decrease. Not a straight line, once again it'll be a curve. And so as x gets larger, y gets less, and it approaches the x-axis out here. Okay, so they're the two graphs. Let's just have a look at, say, an application. If I had $1,000 in the bank, and the good old days, you invested at 10% per annum interest, and it was paid yearly. So after 1 year, you would have $1,000. Now, you could find 10% and add it on. A quicker way of doing that is to just say, well, okay, 100% plus 10% is 110%. So that'll be just 1.1. 110% is 1.1. So that's how much you would have after the first year. So 1,000 times 1.1. After 2 years, you would have 1,000 times 1.1 times 1.1, because this is how much you'd have after the first year. And then you would multiply that by 1.1 to find out how much you'd have after 2 years. 3 years, be 1,000 times 1.1 times 1.1. So that would be after 2 years times another 1.1. So after n years, you would have 1,000 times, so this would be to the power of 3, after 3 years, to the power of 2, after 2 years, the power of 1 after 1 year, so after n years, it'd be 1.1 to the power of n. So that's 1,000 just leave that multiplication sign out. So that's an example there of an exponential function. N is an independent variable. Here's my base. In this case, if we use a, b to the x, b is 1.1 and a is 1,000. So that's how much you would have after n years, an example of an exponential function.